Thank you, Professor Bonwick and Kath, for inviting me to speak. And it's a privilege to be able to address today's conference. As Tim said, I'm just a poor baker, but I've been around a long time, and I've been very fortunate in my career to be involved behind the scenes in product innovation almost all my career. With some large companies, but a very nice time working for an entrepreneur, which allowed me really to get into this sort of discovery space. And I've had some very good sponsors over the last 40 years while I've worked in this space behind the scenes. And 4 years ago, I was able to set this activity, New Food Innovation, up, and I formed a company with a group of like-minded people who also are very passionate about food innovation. So, first of all, I'll do an introduction about the company. And we've got a group of around 8 currently, but we're increasing, of food industry professionals who work in this team. Of which we've got academics, former academics, we've got industry experts from a wide range of large companies, and we've got a range of skills in there covering all sectors of the food industry. And the commonality is having a passion about getting things done about food innovation. So our achievements include we've brought over 40 first-to-market technologies. In the last 4 years, we've pulled together over £5 million worth of collaborative funding. Within the team, we've supervised over 62 PhDs. We've got over 45 patent registrations during our careers. And most importantly is we've got a huge network of direct contacts and digital contacts, which are really, really important from a food innovation arena. And what we do is a set of activities here which cover this interface between industry and the food innovation community. So we provide an open innovation resource for companies where we help work alongside companies to do more longer term innovation. Or we support businesses to do breakthrough projects which they haven't got the resources to do themselves, either the physical resource in terms of people or the equipment, or have access to resources that we can either network or support and carry out for them. We also help academics with this development and translation of their science. And that might involve working one day in working with penicillin, rock 40, or it might be where we're looking at a plant extract that was working with children with autism. We also help entrepreneurs and also people who've got an idea, and we'll help them bring that to life. Collaborative research, where we get involved in things like the Innovate UK projects or Research Council projects, and we're involved in 5 of those, some of them with Tim. We have another program which we call Junior Consultants, where we take good food science or food engineer students from France, and what we work with them to do consultancy projects in companies or with us over the summer. So we get really good quality projects, almost sort of research organisational standard projects. And we do a program where we're improving the employability of students. So we learn them what it's like to work in companies, so they're much more ready to start work. We have an interest in food security and sustainable nutrition, which is very much like the topic that Tim was talking around. And within that, we're looking at a wide range of aspects, from reducing food waste to understanding how we can get people to change their sort of dietary choices. And the last one is where the talk sort of emanates from today, is what we call the innovation distillery, where we work with a range of technologies, whether that's a raw material technology, like I'm going to talk about then microalgae. It could be a piece of equipment, which very shortly we'll have here, which is an electric taste sensing tongue, which will do an automatic analysis of flavour of different foods. And then we'll also look at equipment and different processes, where we're either transferring from another industry, or we're helping someone understand just how it can be used in the food industry. So this is some of the food manufacturers, ingredient producers, universities, spin-outs and startups, global sports stars and celebrities who we've worked for in these last 4 years. So that ranges from Devereux there. Not many people know what they do, but they do 8 billion sausage skins every year. Marson up at the top, they do 1 million poppadoms every week, all made by hand. So there's quite a mix of interesting activities. So not only do we enjoy what we're doing, we have a lot of fun as well working in all of this. It's very stimulating to work in all these sectors. So I'll just want to go through this industrialization of microalgae in the first instance, to talk about how it's made. And I want to sort of stop for a moment and change the paradigm. And Tim set up that today's a very important day, and I think that's why Graham arranged it today, isn't it? Yeah? So, and you'll have probably heard on the news, but that, yeah, it's Back to the Future too. And so, yeah, the 21st of October 2015 is today, and it's what was the story behind this film. But in this film, there were lots of things what were very futuristic, which are everyday now, even though this was produced not so long ago, the film. There was the drones, the iPads, there was video phones, all of those things just not too long ago, which most people can remember the film coming out and all these things on, that seemed to be quite futuristic. And I think this is what's happening with with microalgae. The sort of translation of this biotechnology process has been so rapid. It's been not necessarily going on in the food area, but it's been going on from the energy area, and now it's coming into food. And this acceleration of this translation, the innovation lag, as we would call it, is really short by comparison even to what we've just been talking about with mycoprotein. So, but it started a long time ago. So this is my back to the future approach. I didn't quite segue quite rightly into that, but algae, and Graham will correct me, I'm sure, on this, but was the mother of all plants. And it was a food source for as creatures, and as the evolution started, algae was there, and it's, according to the Smithsonian Institute, it's this diagram's from, it's the mother of all plants. So it's been around a long time. So what's happening in manufacturing now is there's different systems for producing it. In this bottom right-hand corner there, the open pond one, is systems what are being developed in France for farms to help produce feed for animals. The tube system up there is one which is in the back of a container at the IGV in Potsdam in Berlin, which you can hire and bring onto your site and produce algae. But the central one there, the one which is Solazyme, Bungay and Unilever, that's due in 2018 to produce 300,000 tonnes of algae. And this isn't bad to say, it didn't really start until 2003, but I'll go through that. But the process for manufacturing it is speeding up the growth. They use a heterophic system where they can control the growth rate. They can speed up the growth rate of algae. And if anyone's got a pond in the garden, they know it grows quick in sunlight. But you can change the amount of light, and you can make it vacillate between producing protein or producing oil. And that's what these guys have learned to do. And so this is the roadmap that I've produced from just examining what Solazyme have been doing from 2003 up to where they will be in 2018. They're on 100,000 tonnes annually of capacity now there. But in 2003, it started with 1 kilo in the lab. And 2004 to 2009, it was in smallish pilot system up to 2,000 tonnes. A lot of UK government money going in looking at alternative energy source. Obviously lots of problems in that area because of fluctuations in oil prices, and what they've had to start doing is looking at how they can valorize it in other areas. And this is what's been going on with different routes to market. And I'll explain some of those within the next slide. But just to give you the scale of it, during that time, they've established over 300 patents in that area. They've examined over 100,000 species of algae before moving into this food area. So while they've been going on that journey since 2003, they've been selling the energy part to United Airlines, to UPS and the American Navy. And then they've been looking at the oil drilling area and fracking and chemical area, so working with BASF and Flowtech. Flowtech, I can tell you, they might, if anybody interested in shares, they might just be worth looking at. What's been happening in the last 6 months is in oil drilling, the costs for drilling in a pretty typical oil well are really, really expensive. And some reports being published where they're saving 100,000 pounds per day on oil drilling costs at a typical oil well. And that's using the structure of the microalgae, because it's got a very, very tough outer shell still with the lipid inside it. And the pressure that it can withstand as the drill bit hits the rock, it helps actually lubricate it, and it's reducing costs by that 100,000 pounds per day. So just keep your eye on those shares. But also they've been looking at smaller things like taking the fucoidins out of the microalgae, off the surface of the microalgae, to make cosmetics. And I think the cosmetic won 2013, won the best cosmetic in the Paris Cosmetics Show. So just skipping into food. And this is a valorization model which we use just to demonstrate how that commercialization started in 2009 and up to current time. And what they've been looking at really is oils, protein, and whole algal flour. And all of those are very simple processes. Take the algae, take the water away from it, and either dry it and grind it, or press out the oils, or have the high protein material available. So they're very, very simple processes. Grow the material in the big. The best way of describing them, they're like the airline fuel tanks. They're just very, very large tanks that it's grown in. But what they're doing now is behind the scenes is looking at more bioprospecting, so looking at digging for diamonds and looking at really high value material. So there's a huge amount of work going on behind the scenes to look for more added value components, as well as looking at how they might improve the, say, the functionality of protein by looking at different ways of manipulating the protein. So just touching on sustainability here, is when you look at the production of oils, of plant oils, producing oil from algae has got a much lower carbon footprint than most of the plant oils. And then if you look at the amount of water used, it's really, really, really substantial. And look at the gallons of oil per hectare produced. It's a huge, significantly different from all the standard food oils that are used. And then touching on where Tim was as well from a growing plant protein, when you compare it with other plant proteins, the amount of space that you occupy to grow protein using this process is very, very, very low by comparison to anything else. So then you get a super yield really from the amount of space occupied. So the applications in food. Is already, we've been using microalgae oil for a long time. In essence, that's the backbone of all the omega-3 which has been developed with originally with Martech, and then now it's moved into DSM. But a lot of the microalgae, what's used in infant formula, of omega-3 used in infant formula, that's derived through microalgae. There's lots of health-based food products being developed which have got chlorella and spirulina in, and the growth rate in the US of chlorella and spirulina products has been at something like 15% over the last 4 years. So covering a wide range of product applications. So you have oils, proteins, fiber, and micronutrients in there. I'll just point out lutein. That's where I think the sort of Achilles heel is in this, because the material's very yellow, what's produced. And I'll come on to that. But last year, the Solarzyme material at the IFT awards won the most innovative ingredient of the year. You can see how much investments has been done over those 13 years, which is $600 million, 150 scientists involved, and things what I'd said before in terms of the 100,000 strains reviewed and over 300 patents. So a lot of effort, but that's what it looks like. It's very yellow, and so it's really okay in certain products, but not in everything. This is what whole algal flour is. And what we've done with it over the last year, while we've been looking at is try and look at foods where you can utilize this lipid flour, so you can see how much fat's in there, with this fiber content, and there's the relatively modest amount in the whole algal flour of protein and look at its functionality. And what we're finding is it produces a fat mimetic in products. So fiber binds some water. The oil is a very highly polyunsaturated, but it enables us to reduce fat. And in some products that we've been working on, we've reduced fat by over 50%, without adding any additives other than maybe some phospholipase. And in sensory tests, it really performs very, very, very well. So looking at some things what are yellow, so in challah bread, in some types of bread, and in muffins here, which are the American examples, they've been able to reduce fat in all of those, increase fiber, alter all the fat profiles, and in some way make things still taste relatively the same. Yeah, that's just I'm just trying to focus really just on that whole algal flour, and that's really a fat mimetic, emulsifying way of reducing fat in cake, in some types of enriched bread, and it has got applications in things like mayonnaise. So the protein is not a complete protein, but it's you get a very high level of it in the algae. It's capable of producing that amount. It's very high in arginine and glutamic acid, which is very useful for muscle repair. So it's high in those components. So behind the scenes in America, they're looking at how they might utilize this and commercialize this in different nutritional products. So you can add it to baked goods for increasing protein content, add it to beverages, and the things like, I don't know if you know products like Soylent. That's an American product where it's sort of like a meal replacement. So it's added as the protein source within products like Soylent, and yeah, it can be added to bread in that way. So sorry, I'm doing the wrong thing here. But I think this is the most interesting. So the lipid, the oil from it, is it's one of the lowest polyunsaturated fats around, and so it's very, very stable. It's really, really stable, and yet we've had products in front of us where it's actually been the equivalent of cocoa butter as well, and we've taken it to some large confectionery producers. It's been difficult to distinguish between that and say chocolate coating. Difficult to distinguish between chocolate and the product made with microalgal based cocoa butter equivalent. What this oil's being sold as in America is really as a really healthy product, and they're pitching it really to be equivalent of or better than olive oil, and from an industrial point of view, it's very stable in processing. So this is just showing the stability in frying conditions. That it's much more stable than canola. So I think this is really an area where that once it gets approval in Europe, if it gets approval, this is something that can really have an impact if you take out the aspect of the sustainability of it and the ability for it to be so versatile in how it can be processed. It's something that I think could be a really good ingredient. So wrapping up for me, I just wanted to finish on the slide which was saying that, picking up some points from Tim about future design of foods. If you're looking at sort of 2050, the time ahead, for the food industry, I dread to think what the size of like quality control manuals will be in 2050, and how many legal people we'll have to have involved in companies. But from a product design point of view, I think it'll be essential that we look at something what I term the trifecta. Tim used the word trilemma earlier, and I think this is my riposte to it, which is that we've got to think about sustainable societal nutrition. We've got to link the environment to how we design food, so making things that are really sustainable, and think about food security, of how we how we can design a food which fits into those fits all those boxes. And so the term trifecta normally relates to the perfect bet. So my bet for 2050 is that we'll be designing foods like this. But not only that, we'll get consumers thinking in this way, which I think is a much bigger challenge. So thank you very much. That concludes what I was going to say. Thank you very much for your time. Okay.
Hello. It's a quick question on the approval. You mentioned approval, and it's also a question for Tim. Is this a novel food, and is corn a novel food, even though it's been around for 50 years?
No, corn absolutely isn't a novel food. Novel foods regulations came in 1998.
Yeah.
Anything that was on the market before that
was outside it. But what about the algae then?
This is with the chlorella has been used as a food for a long time. So the answer to your question is it's not a novel food. It's already been approved.
Right.
Yeah.
Thank you.
The oils, that might need approval, and that approval is in application.
Right.
Okay.
How do consumers perceive the name algae? Do they like it? Is there anything better?
Yes, this thing's better. Yeah. So, so there's been research done in Europe and in the States, and once they've had the once they've been explained this type of background, it's very acceptable. So I think that there's a degree of skepticism when they've done it without the sort of background, so it might be like 50-50, but as soon as they start to understand where it comes from, then it's very high acceptance levels. Yeah, and it is, rather than say with corn it's a complete food product, this is just really a component within there.
Thank you.
It appears on the label as algal flour. Yeah. Okay.
Thank you. I suppose the question was, with regards to the algae oil, in terms of you saying it has high stability, does it also have any benefits in terms of acrylamide the challenge of acrylamide?
My guess is it would.
Okay.
Yeah, my guess is it would, yeah.
Okay.
Yeah. I know some very bright people who'll be able to give you the right answer for
great.
that. But
Thank you.
It's something that is being measured, yeah. Yeah.
Great, thank you.
Where's the lager breads?
Um,
You know, buy that in a tin format.
you can buy it, yeah, you can get, and just over there, just not too far away from here as well, yeah. So it's
It's a form of algae.
Yeah, it's from seaweed. Yeah, less sodium in this, I guess. Yeah. But no. So it's we're making use of the same type of food source, aren't we? But this is really just growing it and cultivating it in very large vats, and using it for either the sort of industrial source, industrial fuel source, but more recently looking at it from what its potential is in food. And to me, it's quite an interesting area. There's some challenges with it.
We use normal bread quite a lot in our cooking, so
Yeah,
we
yeah.
see how it's the same constituency for the algae.
Yeah, it functionally it performs differently. Yeah, there's much more emulsification in this. Yeah.